Here we're just using log rules to move from log format to exponential format. So this is what it looks like in exponential. And then this is 1/9. Negative here does not mean negative, it means the inverse, the reciprocal of that polynomial. Here you'd get 3x equals 27. 3x equals 3 to the 3, and so x equals 3. This is just some quick solving. Here we're applying the log rules to simplify. Subtraction means division, so here we get log 16 divided by 2, and so this ends up being log 8. Here we have multiplication, addition, which is multiplication. 4 times 2, which is also log 8. Here we have, again, addition, which is multiplication. That would be log 4 times 4, log 16. Finally, this rule is the exponent rule. When you have a multiplier, it can be written in the exponent position for an equivalent statement. Log 16 would be our answer. These are the simplified versions of the original statements. This is a compound interest problem, and the formula, and you'll have it of course, looks a little bit like this. And so if you want to know the amount, your initial principal is 1,000, 1 plus the rate 0.5, compounds twice a year, so twice a year times 25. So this just becomes you putting this into a calculator, and let me do that. Value comes out to be this value here. Again, this is just using a formula which will be provided for you, but here's your principal, here's your rate, here's the number of times it happens per year, and then it is the number of times the total number of years. So that's how you calculate it. What happens here is a lot of students use the same compound interest formula, but this is just exponential growth and decay, and it works as follows. There are 30 items to begin with, 30 bacteria in the culture colony. It's doubling every day for 5 total years, or 5 days, sorry. And so it just becomes your initial amount, your rate, to the power of that taking place. And that is just basically 32 times 30, which is 960. Very simple, actually. You just plug it in and make it happen. This is your initial value, your r to the n. That's all it is, just like this. This time we are actually looking at what's called exponential decay. And the reason it's decay is because we're losing 10%. Now the typical thing is to say, okay, 910 parents losing 10% 3 years from now. This is wrong. It actually should be 910.9 to the third here. Now why is it one and not the other? Well, this is actually a loss of 90% because we're at 0.1. If you're losing 10%, it's 1 minus 10%, which is 0.9. Think of it as how much is left after you've lost the 10%. So 0.9 to the third power times 910 gives us 663.39. And if they're talking to the nearest person, in this case, this is the number we would use. Here again, we just need to know what the parent function looks like. The parent function looks like this. Goes through the point 0 and 1. And the parent function is just 2 to the x. So when we add 4, we know that that just means everything slides up 4. So this guy here that used to be here has gone up 4, so B happens to be the answer here. In this case, they're asking us to solve, but what we notice is that the two bases are different. So the first work is to make the bases the same. 8 can be expressed as 2 to the third, and then this gets distributed. So you get 2 to the x plus 9 equals 2 to the 3x plus 1. And then to solve this, I think you can see we set these guys to be equal to each other. And so 2x plus 9 equals 3x plus 1. Bring over the 2, bring over the 1, and we get our answer of 8 would be our answer. This is really just moving it from one format to another. This is called exponential format, and we want to change it to logarithmic. So if the base is 8, this is where the base goes, the answer, and then the exponent. In the second case, the base is a 3, the answer is 2,187, and the exponent is 7. Here in this case, the base is a 9, the answer is 729, and the exponent is -3. Basically, the idea is if we have it in this format, it can be written in log base a of b equals x. These are interchangeable between each other. Here we are just going to expand it using log rules. We know that division means subtraction, so this would be log 7 minus log 3. Here we know multiplication would be addition, so log 5 plus log of x. Here you have three things being multiplied. That would be the log of 2 plus the log of a plus the log of b. Remember that multiplication, when things are being multiplied, means we add. Multiplication means adding. Division means subtraction. This is again just a repeat of an earlier question, logarithmic form of this exponential. So it looks like this. We write logs as log to the base, the answer, and equals the exponent. This would be how you would write it. Base, exponent, and answer, just like that. These are fun because you're asked to basically solve it. And the trick is, if it's in log format, change it to exponential. So this would be 4 squared equals x minus 1. And then this can just be solved like a normal type of equation, and we just get 17. Same thing here, it's in log form, so change it over to exponential format, and then everything turns into some very basic numbers. And you can see that if we move the 8 to the other side, we get 40. And if we divide by 4, we get 10 as our value. The key to solving is that if it's in exponential format, you just reverse the process. So if this is in this format, change it to this format. If it's in log, go this way. And vice versa. Sometimes if they give it to you in exponential, it's best to go to log to solve it, one or the other.